Hey everybody, welcome to the live stream. And we weren't necessarily planning on doing a live stream so quickly, but because of recent events, we've decided to. We've seen the biggest solar flare we've seen in quite a long time. I haven't looked up how long of a time it is, and to quote Albert Einstein, never memorize something you can go look up. Allow me to get off the screen and put this back on the screen. It's the 131 Angstroms view of a significant M-class solar flare coming from the limb of the sun here, not from the large sunspot 2786, which is facing the Earth. So a prime example of the Earth-facing quiet effect, large solar flare coming off of the limb. And we can't even see a sunspot at this point. So a prime example of the Earth-facing quiet effect. And yeah, thanks for tuning in, Mandy and Nabo J, and for leaving comments. And we're going to show a whole bunch of other views of this, and throughout the day look for at least one more produced video to come out. So yeah, what's everybody into on this fine Sunday? Yeah, it was an interesting daily space weather video. Let me just show you the X-ray situation to show you that GOES 16 measurement of that solar flare. Let's see, there we go. And I'll put your comments back up on the screen. Yeah, so some more luck happening here, or is it divine providence? You tell me. Now, there's no possible way that we could have done any of this stuff on purpose, and we've seen this happen repeatedly on the channel when we do things like inform people of coronal mass ejections long before anybody else on the internet. Cheers! And thanks everybody for leaving comments. So yeah, there's what's going on in the X-ray flux, and here you can see the that flare showing up there. Big flare there happening. So there's the ionospheric absorption of that M-class flare. It happened at about 1310 Universal Time was the peak of that. And let me put back some more interesting solar imagery so we can chat with our viewers and so on, answer any questions. We're also going to cover some science articles. And by the way, if you enjoy the content, press like and subscribe on YouTube, press the notification bell, view our playlists, such as smAsho presents The Sun. What a great opportunity to show some legit data. And let me take that off the screen for a moment and put up some other wavelengths here for you. And just bear with me a quick moment here. Again, leave comments. We'll put them back on the screen momentarily once I get this data back up. So let's see. Let's look at 335 angstroms also. There we go. There's that. And here are your comments. We'll move that to the middle of the screen. Yeah, it's going to be too early to see anything on stereo A, because what you're looking at stereo A is, oh, it shows up really good in 335 angstroms. What you're looking at on stereo A is, that's a coronagraph, and we're looking at the chromosphere mostly here. You know, the corona starts here. So here you've got the chromosphere, and here you've got the corona. And it takes a moment for enough of any ejecta to come out of there. So there could be a coronal mass ejection associated with this. It could be Earth-facing, could be not Earth-facing. Who really knows? You know, if I had to place odds on it, I would say chances are it is not Earth-facing, as there's a lot of space in the solar system, and there's a lot of area for coronal mass ejections to strike, and the Earth is a tiny, tiny little point in reference to that. So the likelihood of it actually striking Earth is pretty low. We saw a lot of X-rays come out of there, and that, folks, indeed is synchrotron radiation. Now, there's no reason to seek out a synchrotron radiation shelter from that, but just to zoom out here, here's you know, there's how small the Earth is. And you got to hit a very small point there if you're ejecting matter off of the sun. So, yeah, you're not going to be able to see anything on the coronagraph images yet. It's probably way too early for that. And, yeah, stereo A. I mean, I'll show you stereo A, but it's going to be too early to see anything. So, stereo, if you go to the Integrated Space Weather Analysis page, you go to page 7. And we'll max out the data on that. So you're not going to be able to see anything from that yet, and that very well might be facing towards stereo A. Who really knows? You can't know until you see it. And when I start to argue with people about whether or not a coronal mass ejection happened, it's just ridiculous, because we had this happen back, I believe it was at the end of May. There was an argument with some certain person on Facebook about whether or not a coronal mass ejection was Earth-facing. And this particular alleged scientist claimed that there was no coronal mass ejection, and we had showed it earlier in the day on the channel. And then I went back and looked, and hey, once again, the attempts at gaslighting failed. So yeah, that's a pretty good one. It shows up really good in 335 angstroms. And again, we'll be making a second video today about this region here. We'll include extreme close-ups and slow motion imagery of it. Yeah, so that's and by the way, sorry, Mr. Keebler, you won't really be able to go out and get any X-rays from this. It's kind of showing up in the South Atlantic. There is the main spot of that, and the activity has calmed back down since then. So let me put up another wavelength here. Put up my Smash News Network test pattern first, and I'll put up some more. Another wavelength for you. Here's 193 angstroms. And this is another one of the ionized UV spectral states of iron. And the 193 angstroms is a good view to see coronal holes, actually. So, yeah. It's, oh no. Sunspot 2786 is right above my head. And yet, we see the solar flares from the limb. And once again, folks, I won't be explaining on YouTube why the Earth-facing quiet effect is a thing. If you're wondering if I think it's because the sun is conscious, that is not why. So that's a great view of 193 angstroms as well. And I wanted to look at some science articles here, so let's just take a moment to, I guess we'll head to phys.org here, because we saw this article clickbaited in 2 different spots. Again, I would remind our viewers, if you enjoy the content, to press like and subscribe on YouTube. Please share with your friends and foes on social media. We've been doing this for quite a while and demonstrating our ability to forecast much, would it be 3 muches? Much, much, much faster than everybody else, much more promptly. If you don't follow us on Twitter, please do. Twitter.com/smashamash. And we had information about the solar flare long before anybody else, and it happened as we were actually creating today's live stream. So we live streamed to Twitch, and then we uploaded it to YouTube. And there were some little weird errors that happened during the YouTube upload, causing us to put up a 4-second video for some reason. I don't know what was up with that. Let me just head to phys.org here real quick and make sure the stream is good, and we are good. So if you head to phys.org and you go to the astronomy and space section, I've noticed that there's a nonsensical article here going on, and I'm not gonna talk about dark matter in this stream, or the lack thereof. What I'm going to talk about is wait for it. Earth faster, closer to black hole in new map of galaxy. Are you scared? Are you spooked? Are you scared and spooked? Well, you shouldn't be, because this is not news. This is just a different measurement. This does not mean that the Earth and Sun have accelerated toward the galactic core. But don't be discouraged by the fact that it is a clickbait title. It's a clickbait headline. And I first noticed this on SciTechDaily.com. But this is an interesting map, as it is showing us the real motion of a lot of stars in the local vicinity. So you can see velocity data, and it just what this means is that the original estimations on the sun's motion with respect to the galactic core appears to be different. And I haven't read the paper yet. I just saw this article this morning. I just wanted to share that with our viewers. The sun is nowhere near the galactic core. I think this changes the estimated real motion of the sun with respect to the galactic core by several kilometers per second. Let me see here. The velocity component of the map indicates that the Earth is traveling at 227 kilometers per second as it orbits the galactic center, faster than the official value of 220 kilometers per second. Oh no, 7 kilometers per second difference. So that's what the article's about. It's not because the sun's going to be swallowed up by a black hole in next year or indeed next month. So. And, we try to debunk clickbait here on the regs, because there's a lot of clickbait on the internet, and there are a lot of people that have agendas and so on, and I'm pretty sick of it. I'm pretty sick of the COVID. And hey, there we go. That's better. So yeah, I prefer to be objective, as I answer to a higher power. All right, so let's get back to some more images of this solar flare. We're going to switch to 94 angstroms is the next one. And I downloaded these just for you, the viewer. So there you go. There's 94 angstroms, and this, along with 131 angstroms, takes 10 images per minute instead of only 2. So 171 angstroms and 193 and 304 angstroms, those only take 2 images per minute. 94 and 131 angstroms take 10 images per minute. If I had to guess, I would say that there's probably some ejecta associated with that. Because an M-class flare is pretty significant, and it was a high-level M-class flare, not too far from an X-class flare. And let's bring your chat back up on the screen. I'm gonna make this a little bigger. There we go. There's 100. How about 110%? Where'd my scroll bar go? Oh, 100%. All right, that's fine. And I'm just gonna scroll. And thanks everybody for leaving comments once again. So yes, Mandy, there was indeed a coronal mass ejection on the far side. That was like 2 days ago. Yeah, YouTube fraudsters' heads are going to explode over that. And, yeah, so, again, share the content on your social media, especially if you've got a lot of followers. Make sure you follow us on Facebook as well. Now, if you've noticed that there are 2 Daniel Nigras on Facebook, it's because I've got 2 accounts. My original Facebook account got to about 5,000 friends, and that prompted me to make a second account. And so when we share on Facebook, we're going to be reaching about 6,000 to 7,000 accounts on there. And mysteriously, it doesn't seem to increase our viewership. So some of us find that a little bit strange. So yeah, so make sure you follow us there. Thanks to our new followers on Twitter. We recently gained some Twitter followers. I'm not exactly sure the mechanism behind that, but it's greatly appreciated. And again, we put out the information about this solar flare only minutes after it occurred on Twitter, and it all has to do with the ability to copy paste images and so on. As all the different sites have exclusive content on them, visit the links below the video in the description for all kinds of other stuff associated with us. We've also created a website, smashomash.com and smashomash.org, which will just route you to smashomash.com. Visit the links there. You'll find all the social media. In the upper right, underneath the arrow, there's a pop-out drawer that will show all of our social media accounts. And how about just some random news stories? What else is everybody thinking about? I'm not going to just talk about coronal mass ejections all day because, Tommy, come on. What's so exciting about a massive solar flare and coronal mass ejection? No big deal. What, I should put it back on the screen? All right, I'll put it back on the screen. How about 171 angstroms? My personal favorite. There you go. There's 171 angstroms. Yeah, so what's everybody up to on this Sunday? Are you going to go ride your bike? It's pretty cold here in Pennsylvania. I saw some frost, and we're located here in Lehigh Valley. I won't get any more specific than that, as there are a lot of psychos on the internet. Please don't be a psycho and try to dox anybody. Don't send your people to come try to harass me in person. They'll have a very, very bad day. So yeah, good view in 171 angstroms also. And this thing, again, I'm pretty sure this thing is going to produce some sort of a coronal mass ejection. Here's 304 angstroms. And you can make all these movies yourself on helioviewer.org. And we'll actually include these and some more later in the day after this fully propagates. And we'll do an analysis over whether or not there is a coronal mass ejection and sort of the direction analysis of that coronal mass ejection. We've been having some great fun on Twitter lately. So again, I highly encourage you to follow us on Twitter. I somehow doubt that I'll get banned from Twitter, as I know how to not talk like a crazy person, as I don't really generally talk like a crazy person. Because remember, folks, it's not about having crazy thoughts. It's about crazy behavior. So if you're out of your damn mind, well, all you've got to do is behave like a sane person, and who's going to know? If you think somebody's reading your thoughts, you're crazy. By the way, if you haven't tried Watermelon Crush, highly recommended. Let me give you a little recipe here. Now, I'm not a big soda drinker. Next time you feel like buying soda, if you think soda is too sweet, buy some club soda and mix them together half and half. That's about the right level of sugar for me. It's called the BRCS. Are you familiar with the BRCS number? The BRCS number is the amount of sugar in an aqueous solution. In other words, a higher BRCS number would be something like orange juice has a BRCS of like 8, and then Gatorade would have a BRCS of like 4, which is why it tastes more refreshing on a hot, sunny day. Little nutritional fact there from a pro cyclist. And little background on me, I became a pro cross-country mountain biker back in 1999. And yeah, so yeah, what else is going on, folks? It's already turning out to be an interesting day. Yesterday I woke up with massive number of lulls. So yeah, leave us a comment, let us know what you're up to. And I will put your comments back on the screen in a moment. Let's see here. Yeah, no X-ray sunbathing today, Keebler. Yeah, let me put the solar images back up on the screen here again. I'm going to actually put the 131 angstroms back up. There we go. And here are your comments. And I'll scroll all the way through them again in case anybody just tuned in. Kablooey. So yeah, it's an interesting day to be a solar forecaster again. Once again, the sun helped us out by going, hey, look at me, here I am. And there's a lot of stuff that does that. I don't know why people don't pay attention to the correct variables. I mean, we've been encouraging people to pay attention to the correct variables for a long time, and they just don't listen. So, you know, part of the reason why we make daily space weather videos, let me give you some background to our daily space weather videos. The reason that I make daily space weather videos is because I look at certain data every day. And what I noticed was that nobody else is doing it. Nobody else is tying the correct data together and helping anybody to understand the physics. And I've been attempting to figure out how the variables relate. The only way to really understand science, folks, is to immerse yourself in the data. If you don't immerse yourself in the data, you will not understand it. If you don't look, you certainly won't see it. Oh my God, Nibiru got sucked into the sun. And so, yeah, so we noticed that there were other channels making daily videos about solar activity, and I was highly disappointed in them because I didn't think they were looking at relevant stuff, and I still don't think that they're looking at relevant stuff, and I think a lot of them are complete hack frauds without mentioning any names. I certainly won't mention any names because I don't want you to go view their channels. I want you to view our channel. Yeah, so that's part of the reason why we make the videos. And part of the reason why I don't have a degree in astronomy is because what I discovered in the mid-90s is that, well, college is ridiculous, first of all. I saw the writing on the wall, and I'm not a fan of the general ed requirements. So I didn't want to waste so much time, energy, and money in college. And I realized that if I would have gotten a degree in astronomy, I would have spent years and possibly decades, if I had gotten a job with NASA, measuring things like the redshift of Cepheid variables. And if you're not familiar with that, Cepheid variables are a specific type of variable star which are considered to be predictive variable stars and can be used in order to get distances and redshifts to figure out things like relative motions. And I didn't really want to do that because I was more interested in the big picture. So what happened was in the 90s, I got out of college because it's a disaster. And originally I was a computer science major, and then I became a psychology major, and then I became a general science major, and then I said, I'm done with this, and I decided to become a pro athlete. So that's sort of how that happened. Because really, there's no time limit. When people say, you should have done this and you should have done that, most things in life you're still able to do. it's not a lost cause. If you want to go back to school and get a degree when you're 80 years old, why can't you? So anyway, that's sort of how it worked. And in that period between when I was in college and the last maybe about 6-7 years ago, I was trying to get people to listen to me about special relativity and time dilation. Are you familiar with this? As you travel closer and closer to light speed, your clock slows down in reference to somebody who is stationary. And I was trying to get somebody to listen to me about how to conduct an experiment on how to either prove or disprove special relativity. In that, if kinetic energy is somehow related to how fast time elapses, well, perhaps there's some sort of a relationship between moving slowly, and I guess I won't get into the weeds on that because that is a mess. But anyway, I had the actual experiment for that, and I caused a lot of people to get very confused about how nature works. So yeah, let me get back to your comments here, and I'm going to close this thing out. I may do a second live stream, but we'll certainly do another video about solar imagery today. So yes, Nibiru is finally sucked into the sun. At least, thank goodness for that. We don't have to worry about Nibiru anymore, as it's been eaten. Just kidding, folks. It's not a thing. It's not a thing. And thanks for tuning in, everybody. Let me name everyone. Mandy, and Nabo J, and Mr. Keebler. Is that Heslin? Mandy Heslin. Also, thanks for commenting, Nastu the Brony Slayer, and Siesta. Cheers, and good morning. And Nastu, I need to correct you on that. We don't see a coronal mass ejection yet. We're looking at a solar flare here. So don't get the two confused. Solar flares are photons. Let me just bring up the graph. Photons in the form of X-rays. That is a solar flare. A coronal mass ejection is protons, mostly hydrogen nuclei. Photons, protons. Very different, especially in their mass. So we don't see a coronal mass ejection yet, although there probably is one associated with that. It would be of no surprise at all to see a coronal mass ejection there, but you have to wait until the coronagraph imagery is old enough for it to show up on the imagery. So let me just show you what I'm talking about here. I'm going to go back to HelioViewer, and this is how you do it. And sadly, we see old data. So when you look at, let me make sure this is on screen. So when you look at the LASCO C2 and the LASCO, if you click newest, right, there's the newest image, right? Let me go to 304 angstroms here. There we go. So there's 304 angstroms and the LASCO C2 coronagraph, although the data is like 5 hours old. So that's just no good at all. And so there's really not a lot to tell you about that. Let's go to the LASCO movie theater here to show you how this is done. If you type in Soho movie theater, you click C2. I'm going to do 1024 resolution and just today's imagery. Click generate, and I'll bring up my Smash News Network test pattern, since we're the least busted name in news. Completely not busted. And let me just talk about being busted while that loads. Here's the way a legitimate news source reports on things. What we legitimate news sources do is we report on stuff, and we do our best to report the truth. If somebody calls us on it and cites the fact that we're incorrect about something, what we do is we don't go back and delete our videos. The best thing to do is, if I say something wrong in a YouTube video, is to go back and show a clip from the YouTube video and then explain why I was incorrect in a second video. That's called a retraction. So, for example, organizations like the Washington Post and the New York Times, former news agency, when they print a front page article with massive headlines that says, "smAsho Mash is a fraud," everybody reads that, and then 2 weeks later, when I call them and I say, "Hey, but I was right about that stuff. Could you print a retraction before my attorneys contact you instead?" And they go, "Oh, you're right. Look, you showed the real data on cosmic ray flux, not the garbage data from Thule Neutron Monitor. We'll print a retraction for you. It'll be in tomorrow's New York Times." "Okay, yeah, have a nice day." Then you go back and you notice that it's not a massive headline anymore. What did they do? Did they try to cover up their fraud? The cover-up is always worse than the crime. And these news organizations, they have a tendency to print their retractions in tiny, tiny fine print on page 14 underneath an ad for the local grocery store, as opposed to doing anything to, admit that they were wrong. I don't know why it's such a big deal, because the way you retain your credibility is to immediately admit that you were wrong and then change your thinking about something. So if you've seen me flip-flop on something, it's because I got new information or somehow my mind was changed for whatever reason. You won't see me just doubling down and tripling down and making up data and lying to our viewers, because your credibility, once it expires, it's gone, folks. So, your sacred honor and your credibility. Have ethics. That's the point I'm making. Have ethics. So here's the view from the LASCO C2, and you can see that we don't see any coronal mass ejections here. That's the latest data that I can get for you there. Let's see. The last frame here is... See, that's old. That's the last frame is at 9/12, and we're already beyond that time. So maybe if I press refresh, let's see what happens if I press refresh. So we're only going to bring up today's data. We're going to bring up our viewer comments. Let me move this back over here. Yeah, so there's today's data. And again, keep in mind, folks, you can have a coronal mass ejection on the opposite side of the sun and have part of that ejection end up on this side of the sun. So there's first of all, number one, our channel has shown over and over again that you do not need a solar flare for a coronal mass ejection. You don't need to see a massive influx of photons for a massive influx of protons to happen. So that's something important to remember, because we showed many coronal mass ejections right around solar minimum when there was absolutely no flaring and no sunspots, sometimes for like a month in a row with no sunspots, and we could still see coronal mass ejections. So again, don't get them confused. Also, you could see a solar flare on this side of the sun, which propagates a coronal mass ejection on the opposite side of the sun, and vice versa. So it's just a prime example of, if you don't look at the data, you're not going to have the information. Do not just assume that somebody is correct because of their reputation, because reputations evaporate in one Facebook comment. One Facebook comment, if you are called out on citing incorrect information, and you just double down on it and you don't even look up to see whether you're incorrect because you're you and you're so special and you're so important and your reputation is so impeccable and you're so unimpeachable with your massive credibility, but you don't actually look and see if you were incorrect, and you just suggest that you've shredded me on the information, you've shredded your credibility. And look, once you shred your credibility, where is it? It's toast. It's toast. Toasty toast. And I did not mean to put that on screen. Didn't mean to show you how the sausage is made, folks. By the way, if anybody ever wants to know how to use OBS, I have no problem sharing some of our techniques, although some of our techniques are trade secrets. Oh my God, the place started on fire again. Anyway. Let me click your link. I'm going to actually click your link, nay. Oh, that's no good. That's not helping anybody. All right, so again, I like to use the Integrated Space Weather Analysis Center. And wow, look, there's the latest image. All right, you know what? We do have an image here. And this is a significant event here. So there's a still image. And it looks like a lot of ejecta. Looks like a lot of ejecta, and it doesn't look Earth-facing. It looks like it'll miss the Earth to the south, and most likely the southeast if I had to place money on it. Let me see if this actually loads now. Oh, there you go. There you go. There's what's going on. Let me put your chats back on the screen. So once again, is it luck or is it divine providence? That does not look Earth-facing. You can see right here that this ejecta is kind of moving to the south a bit. And there's a whole lot of ejecta on the opposite side of the sun. So here's a prime example of a coronal mass ejection that is not Earth-facing. That is a big one. And a solar flare that is detectable at Earth. So there you go. It's complete with date stamps. Nope, that's the real deal. And that is a big coronal mass ejection. Some of that could actually be Earth-facing there, as there is a lot of ejecta. You can see some even up here. Let me get your comments off the screen and make this a little bit bigger. Just enough to include the timestamps. There you go. There could be an Earth-facing component of this. And for you new viewers, stereo A is located at Lagrangian point 5. So the Earth would be out in this direction. That's about the general direction of the Earth right there from Lagrange point 5. So stereo A is located right here, looking in this direction, almost directly toward where that coronal mass ejection, where that solar flare likely propagated from. And that is certainly the biggest coronal mass ejection probably that we've ever covered on the channel here. So, and we intentionally started making daily space weather videos at solar minimum because we wanted to show everybody the sun ramping up in activity. Now I started looking at space weather on a daily basis, not every day, but back in 2003 or so, 2002 I'll say. Back when I was an insurance agent, licensed in 49 states, I used to go to work, and one of the things I would actually look at was the space weather at spaceweather.com. Yeah, there could be an Earth-facing component there. We're going to go back to the LASCO and see if that's been updated yet. We'll also look at HelioViewer once again. Yowzers, that is quite the CME. All right. So check that out. It still looks like the majority on the Earth-facing portion is headed to the south instead of directly toward the Earth. But there is still some ejecta there. I would say if anything will strike the magnetosphere, it'll be fairly weak and fairly uneventful. That would be my best guess as of the current situation. Let me take that back off screen. What the heck? I don't know what happened. Did I lose the screen there? I don't know what was going on. All right, so let's see here. We're gonna head back to the Lasco movie theater. Maybe the C3 is working out better. Let's see if we can see anything at the C3. And this might look very deceptive as we see ejecta on the opposite side of the sun. Sometimes this has got a very deceptive look to it. Nope, the data's too old there. So it's interesting that we see more data from stereo A. Anyway, there's the 335 angstroms view again. Here are your comments. I'll scroll back through these again for anybody who's just tuned in. And we're going to have to close this thing out pretty soon here. Any other sort of comments or anything you'd like us to talk about, speak now or forever hold your keys. All right. I guess I'm going to have to close this thing out. Thanks again for tuning in, everybody. Hopefully the place won't start on fire. There we go. And again, look for 1 or 2 more videos coming out today. We'll do a little bit more to analyze that, and we'll put up probably 2 videos. One just about the sun. In fact, we'll probably cover all kinds of different views. We'll cover it from stereo A. We'll cover it from the SDO. We'll cover it from the SDO and from stereo A. And if we see that the Soho Lasco images have finally updated, we'll also include those. Thanks again. I've been your host, Dan, aka smAsho. Please visit the links below the video. Support the channel if you are willing and able. Share on your social media, etc. We'll see you next time. And here's me. Shh. I've started on fire. I've got a fire within me, folks. A fire.